Once the log curves are converted to a point set, I'll typically go into data analysis and create histograms and cross plots to look at and understand the data and probably clean up some outliers. So I've already done that step, and you'll see that I have a clean version of my raw well logs. So let's go back to the Earth Modeling module and go into the next workflow step. And I'm going to click on the Stratigraphic modeling icon to open up that task pane. What you'll notice is that there are 4 subtask panes, and we're going to start at the top and work our way to the bottom. So from the framework over here, I'm actually going to create my geocellular grid. So I would select that framework, initialize it, and it'll recognize in this case that there are 4 reservoir intervals based on the 5 surfaces. I chose to use parallel to the top layering style for all 4 intervals, and I defined a layer thickness of 2 meters for each of the intervals. I could have done a parallel to a base or a proportional. Once I've created the layering style and define the number of layers, I'm going to do the actual grid geometry. Now I have a couple of different ways I can do that. What I'm going to do is turn on a bounding box over here and show the area over which I want to limit my grid. Now I could just define the grid aerially based on this bounding box, but I'm going to go into the map view, so I'm going to activate the map view over here, and I'm going to show you a bounding box that I created that I actually had digitized. So I'm going to load that grid in. I actually manually digitized this boundary here, and that's simply I just activate the digitize and then digitize it, and then I also limited it to 2,800 meters because the framework actually goes far deeper than the oil-water contact. So I created just enough depth below the oil-water contact to give me a good aquifer system. And then I created the geocellular grid. Once I actually create the grid, it would automatically display in the cube view. So I'm going to go ahead and turn off the framework and show you the box probe over here, which is the geocellular grid, and it's color coded here based on the interval IDs. And I could show you the framework of the grid. And in this case, remember, I did parallel to the base, and you can see that there is some onlap here on the from the interval 1 on to interval 2. Once I define the grid geometry, the next step is to define the lithotypes that I'm actually going to model. In this case, there's actually 9 different lithology codes, and I'm just scrolling down here to show you that there are 9 different lithology codes. I have to define these. And the way I do that is I'm going to load in my cleaned data, and then I'm going to pick up the grid that I just created, and then I'm going to choose either from this library some names, or I can actually create my own names if I don't see something that I actually want to model. And these are the actual lithotypes that I'm going to create in the model. And down in this part of the panel, I'm simply going to assign facies codes to these different lithotypes. So you'll notice that I've actually grouped facies codes 0 and 1, and I called those tidal channels, and they occur in interval 4. Facies code number 2 is a shale, and it's only in the bottom 2 intervals, etc. And I've lumped actually upper and lower shore face, so I've created a single lithotype. I don't need to model those separately. And I also found that I could lump inner shelf and middle shelf into a single lithotype. So from the 9 facies codes, I'm actually going to model 6 different depositional facies. Once I define all of the lithotypes, I'll click the apply, and it'll create a color bar, and it actually gives me then statistics of the facies assignments to the different lithotypes and gives me some statistics. There are two additional workflow steps following the lithotype definition, one of which is optional. The optional step is the seismic attribute blocking onto the 3D grid. In this case, I don't have any seismic data to block onto the grid. This would be a step for populating the 3D geocellular grid with a seismic attribute that might relate to a property that you want to map. For example, acoustic impedance with porosity. So we'll proceed to the well blocking, which is the blocking of the point set. Recall that I cleaned up the point set and I created a grid, and on that grid I defined the lithotypes. Now I need to block the information onto the 3D geocellular grid. In this case, I'm going to look at how many points are within a single cell through which the well passes, and I'm going to average that information based on the lithology it's selected. So in this case, I chose random, but there are a number of different upscaling methodologies from which to choose. Once you've selected the method of averaging, create a new point set name, because recall that this is going to be a coarser version of the original input data, because this is going to be at the scale of the grid. This is at the original sampling rate of the log data. Once I block the data, I can get some additional statistics. The statistics in this case are based on the lithologies, and it creates a vertical proportion curve based on all the well data. Let's take a look at interval 4, and I'm going to hover on the image here of the lithotype proportion curve, and I'm looking at K layer 68. Here we see that there's 50% tidal channel, 5% shale, 40% lower delta channel, and 5% shore face. So I can see vertically how much lithology of each lithology that I have in each interval. And we're going to use this in a subsequent step to define a three-dimensional proportion map, or 3D volume of the proportions, that's going to be used in the lithology modeling.